In this video, we will be learning about the concept of exponents. Instead of telling you how to solve exponential statements, I'm going to show you how exponents work with a concrete example. This will make it easier for you to understand and remember how to solve exponential statements later. So, exponents are a simple way to write repeated multiplication. Multiplication is a shortcut for addition. Now, it's possible to get these mixed up and think that exponents are repeated addition. So in this video, we will look at a concrete example of how multiplication is repeated addition, and then how exponents build from that. Exponents are a shorthand for multiplication. Multiplication is a shortcut for addition. Exponents are a shorthand for multiplication. And what shorthand means is that it allows us to write repeated multiplication in a simpler way. So let's see what that looks like. How many beads do you think are in this chain? How could you figure that out? Well, you could count every single bead, but that would take a long time. So let's look for a pattern. Maybe you notice that the amount of beads in this bar is being repeated. So in one bar, we have 1, 2, 3, 4, 5, 6, 7 beads. So we could add all of the sevens together. So you'd have 7 plus 7 plus 7 plus 7 plus 7 plus 7 plus 7. But maybe there's a faster way. Do you see anything repeating again? Well, we have a lot of sevens being added together. So let's see how many times we have 7. We have 7 one time, 7 two times, 7 three times, 7 four times, 7 five times, 7 six times, and 7 seven times. So we can write 7 times 7. And that's what multiplication is. It's repeated addition. It's addition faster. Do we see a pattern again? Maybe there's an even faster way. Well, we have 2 sevens being multiplied. So we can use exponents. What you do is you find the factor that's being repeated, and you write that here. That's your base. And then you look at how many times it's repeated. And here we have it 2 times. So we put a 2 for our exponent. So this would be 7 to the second power, 7 raised to the second power, or 7 to the second. But whenever a 2 is the exponent, it has a special name, no matter what the base is. The base could be anything. But if a 2 is the exponent, then we say that number is squared. So here this would be 7 squared. Why would we call it 7 squared? This is the exponential form, and this is the expanded form. Do you see a hint in the expanded form, 7 times 7? Or in the exponential form, 7 squared? Let's look at our concrete example and see if we can find the answer there. If we move it like this, let's see what happens. Does this look like anything familiar? It looks like a square. The same number of beads that are in here are also in here. This has just been bound together in such a way that we can clearly see it is a square. What makes a square a square? Well, it has the same size length as it has width. Let's check. Okay, the length is 1, 2, 3, 4, 5, 6, 7, and the width is 1, 2, 3, 4, 5, 6, 7. Okay, so it is a square. When we write 7 squared, what we're saying is that we're taking 7 and using it as the length of our square, or you could say the base of our shape. And then we're making a square from that base, or that side. 7 squared is a base of 7 that has been made into a square. The same number of beads that are in here equals 7 squared, and it equals 7 times 7. Why don't you give it a try? Here we have the exponential form 3 squared. Now you write it in expanded form. So pause the video and think about what your answer would be. Did you get 3 times 3? So we have a base of 3, and we're going to repeat that 2 times because we have an exponent of 2. Let's try another one. Here's the expanded form 9 times 9. You write that in exponential form. Did you get 9 squared? We have a base of 9 repeated twice, so we put an exponent of 2.